Bismillahirrahmanirrahim. Dear students, welcome you all to the industrial pharmacy class. As you know, the industrial pharmacy several class having the course code PCU608, and today's our lecture. Overall lecture number is 15, and you remember that this is the 8th week of the online classes of the semester, and this is the first class of the 8th week, and overall lecture number is 15. In the 15th lecture we will study about the sterilization. You have studied definitely in the microbiology or in the dosage form or any other courses a little bit about the sterilization. Today we will focus on this topic, and the objective of this topic is to learn about the sterilization and related survival products. We will discuss that what is sterilization and what are the various methods of sterilization. Dear student, after the completion of this lecture, you will be enabled to learn about the introduction to the sterilization and different methods of sterilization that is described in the United States Pharmacopoeia, abbreviated as USP. The 5 methods of sterilization including steam sterilization, dry heat sterilization. Steam sterilization is also termed as moist heat sterilization. Another one is direct heat method or the dry heat sterilization. Sterilization by filtration, sterilization by ionizing radiation, and ultimately the fifth one, that is gas sterilization. First of all, I would like to tell you about the sterilization. In short, we can say that sterilization is a process by which we kill or remove all forms of microbial life, including the endospore forming bacteria. From endospore is also removed, and a material or an object or a formulation. If we are interested to sterilize a product, to sterilize a material or sterilize an object, it means that we are going to kill or remove all types of the microorganism, including the endospores of the bacteria. Some bacteria are forming endospores that are termed as these are termed as endospore forming bacteria, and sterilization means the removal of all these microbial life. After that, I would like to tell you about the methods of sterilization. There are different classification of methods of sterilization, but according to the USP, and there are 5 sterilization processes which are described in the United States Pharmacopoeia, and you can see on the screen. First one is steam sterilization, dry heat sterilization, filtration, gas sterilization, and ionizing radiation. These are the 5 methods or 5 processes of sterilization that were described in the USP. All are used for parental products. Among these 5 processes or methods of sterilization, all of these are used except gas and ionizing radiation. You can check our that is the gas, and ionizing radiation. These two, which are widely used for devices which are used in the parental products or any other devices which need to be sterilization, and these are sterilized by the gas and ionizing radiations rather than the other methods which are used for parental products. And these two are widely used for the devices and surgical material. We have heard about the materials that is used for the surgery, for the surgical operation or the surgical procedure. It needs to be sterilized. Otherwise, different contamination or different infections are caused in the patient after the surgery or during the surgery due to the devices or surgical materials that are not properly sterilized. Before going to extend our discussion, sterilization can be classified as physical methods of sterilization, chemical method of sterilization, or mechanical method of sterilization. Sterilization processes can be classified as physical include dry heat sterilization, moist heat sterilization, that including the steam sterilization, and radiation. These are the three types that is categorized under the physical method, while chemical method including the gaseous sterilization and disinfectant that is normally used for the surface sterilization of the machine or the surfaces in the different areas, and the pharmaceutical industry which need to be sterilized, and the mechanical method, that is the filters are used for mechanical purposes of the sterilization, and that is the filtration method is one of the method that is required as mechanical sterilization. Before going to discuss these topics one by one, I have told you about the sterilization, and the first one is the physical method, and it is the dry heat sterilization and moist heat sterilization. As you know that autoclaving is one of the examples of that particular moist heat sterilization, and here you can see on the screen 121 degrees centigrade for 15 minutes time that you have studied in the microbiology or any other courses, at 121 degrees centigrade for 15 minutes that is time for the sterilization, that is by the moist heat sterilization. Steam sterilization or moist heat sterilization means that exposure of microorganism to saturated steam under pressure and an autoclave that achieves their destruction by irreversible denaturation of enzymes and structural proteins. Structural protein and enzymes are denatured by using a saturated steam, but remember that the steam is under pressure, and pressure temperature is maintained to a certain limit, and within that specified limit the microorganisms are exposed to that particular condition of the saturated steam under pressure, and by this way their destruction has been occurred by the irreversible denaturation, that is not reversible. Once it is destructed and denatured of enzymes, denaturation of enzymes and structural proteins are destructed, by reversible mechanism, and that is difficult and completely removed from the particular batches or particular areas which is sterilized by this way. Dear students, as you know that the temperature at which denaturation occurs, denaturation of that particular microorganism that is responsible for not only the denaturation of the enzymes but also the structural proteins are denatured irreversibly, and by this way the microorganisms are removed or killed from that particular batch or products. The temperature at which the denaturation occurs varies inversely with the amount of the water present, and sterilization and saturated steam this require precise control of time, temperature and pressure that I have told you. That is the specific temperature is required, and specific time limit is also required, and as well as the pressure in order to get the point of sterilization, and that is the sterilization by the steam, that is the saturated steam. As displacement of the air by steam is unlikely to be widely achieved, the air should be evacuated from the autoclave before admission of steam. Air should be evacuated, air should be removed in order to precisely and accurately during the process of sterilization. This method should be used whenever possible for liquid preparation and for surgical dressings and medical devices. The displacement of air by steam should be done in order to get readily achieve the process of sterilization. Before going to this one, I am going to tell you that what is the specific temperature. The batch sterilization, including the autoclaving, is one of the examples of the steam sterilization, and here 121 degrees centigrade temperature is maintained for 15 minutes, but remember that the pressure is also 15 psi. Pressure, that is 15 psi. Psi is a pressure unit per square inch, and hereby that is temperature. What is the temperature for steam sterilization? Temperature is 121 degrees centigrade. Remember that here you should mention the unit with the temperature, because there are three different scales for measuring the temperature, and you can put this decimal this point of the particular degree centigrade, 121 degrees centigrade, and the time specified for that is time is 15 minutes. Is it clear now? I think so. These are the condition for the autoclaving. The temperature is 121 degrees centigrade, time is 15 minutes, and pressure is 50 psi. The next one, that is dry heat sterilization. And the dry heat sterilization, there are certain materials which are not properly sterilized by the moist heat sterilization because of the several problems related with their stability or their nature. They are not sterilized by the steam sterilization, moist heat sterilization or saturated steam sterilization. In the dry process, this is the dry heat processes. The primary lethal process is considered to be oxidation of cell constituents, and dry heat sterilization requires high temperature than moist heat and a longer exposure time as compared to the moist heat. These are the two differences. It requires not only the high temperature but also require comparatively to the moist heat sterilization. That's required high temperature, but comparison with the moist heat and longer exposure time compared to that particular moist heat sterilization, then we have to discuss in the previous. This method is therefore more convenient for heat stable non-aqueous materials that are directly exposed to heat, and it is convenient and suitable appropriate method for the heat stable that are not deteriorated by the application of heat exposure to the heat directly, and non-aqueous materials that cannot be sterilized by steam because of adulterous effects or failure to penetrate, which are non-aqueous in nature and which are not perfectly or precisely or accurately, or we can say that it is not properly sterilized by the steam sterilization or moist heat sterilization. So the dry heat sterilization is preferred in these cases, and for those materials which are heat stable. Such materials include which are sterilized by the direct heat, including the powders, oils, glassware, and some oil-based injectables. These are sterilized by this way. This is the point, and some of the examples that sterilize the material that is sterilized by the direct heat sterilization or dry heat sterilization. Preparation to be sterilized by dry heat are filled in units that are either sealed or temporarily closed for sterilization, and then direct heat is applied for that particular material or that units that glassware, and that are either temporarily closed or either sealed, and sterilization is done by this way. Attention please for this one. The entire content of each container, which are either closed or temporarily closed or sealed, and each container is maintained in the oven for time and the temperature given in the table below. You can see in this table they're showing the conditions for dry heat sterilization, including the conditions for the dry heat sterilization. You can see in the column temperature, and the next column that is the minimum sterilization time. These are the two parameters. You can see from top to bottom the temperature will be kept temperature 160 degrees centigrade, and minimum sterilization time should be kept, in this case it is 180 minutes. But if we increase the temperature 10 degree more from 160 to 170, just 10 degrees centigrade increase in temperature, then the minimum sterilization time, that is just 60 minutes, it is you can have mentioned if we put the value rather than 160 180 minutes 3 hours, and for there this one I'm going to put an hour. For this I'm going to put half hour, and I will remove from here the minute, and I will put here the minute, this can be done in the open book or any other examination point of view, or just answering the question and their answers. But if you remember only one, you can easily convert to another one. You can see in the top that is the 180, that is 3 hours. From 3 hours to the time is reduced to an hour. 2 hours, that is less time as compared to the first one. But if further increase the temperature from 170 to 180, just 10 degrees centigrade, then in this case the time is half compared to the first one, that is 170 earlier, and the first one, that is 160 to 170, 2 hours, that is a shortage of time and saving the time as well. If we further increase this temperature from 180 to 190, definitely the time from 30 minutes or half hour will be decreased. And if we reduce this one, if I put the value here, for this, if I put the value for this 150, then what will be the time? The time will be more than 80, more than 3 hours. So you can check, you can see, and you can note the temperature increase is inversely proportional to the minimum time, sterilization times. The time will be lessened if the temperature is increased. If the temperature is decreased, the time will be more or prolonged for sterilization. These are the conditions for the dry heat sterilization. Another method for sterilization, that is filtration methods, and one is filtration. It is one of the mechanical method. Sterilization by filtration is employed mainly for thermolabile solutions, which are heat sensitive materials that are not processed by the either by the direct heat or by the mild heat sterilization or autoclaving. These may be sterilized by passage to sterile bacterial retaining filters, for example membrane filters. These are made up of the cellulose derivatives, etc. Plastic, porous ceramic, or suitable centered glass filters, or combination of these. The filters which having the capacity to retain the bacteria, these are sterile in nature, and by using materials either by the membrane filters or the plastic, or the combination of these can be used for sterilization by the way of the filtration. By this way the bacteria are retained by the particular filter selected. Asbestos containing filters should not be used, and we have discussed this point as well as in the filtration chapter in the 7th semester. Appropriate measures should be taken to avoid loss of solute by absorption onto the filter and to prevent the release of contaminant from the filter. And recalling from the 7th semester that what is the criteria for suitable filters and what is the efficient filters criteria that should be selected. We have discussed in the previous semester. You can also consult over there in the sterilization process. Let me check that again, that filtration method and what are the different filters. You can see the filter selection. There are different criteria for filter selection, which must be different factors should be considered. That what is to be filtered, liquid or gas, what liquid or gas is to be filtered, what is the pore size required to remove the smallest particle, and what is the desired flow rate, what will be operating pressure, and what are the inlet and outlet plumbing connection, what is the operating temperature, and can the liquid to be filtered withstand the special temperature required, what is the intended processes, clarification or filtration that we have studied in the previous semester. Will the process by sterilization filtration that can be processed by filtration or not, then we will select the proper filters. Will the process be a continuous or batch, what is the volume of to be filtered, that is filtered easily or not, what time constraint will be imposed. And this is the criteria for selection of the filter selection, that how the filter is selected, what are the different parameters and different points which must be considered while selecting the filter. And these points should be considered while selecting the filter. And before going to discuss in detail, I'm going to tell you about the asbestos, that why asbestos is not used, and what is the drawbacks in asbestos. That we have pointed out that asbestos is not used, and you can see in this one that the asbestos pad has significant absorption and absorption properties in chemical pre-wash and pH adjustment are required to prevent interaction with product. Failure to achieve sterility may occur with asbestos pad owing to blow through and channeling of medium of organism when critical pressures are exceeded. By this reason, we can say that asbestos is not preferred, and these are avoided. And in this case, the membrane filters don't have these disadvantages, and that's why the porcelain candles and the asbestos pads are no longer considered media of choice for sterile filtration. And this is a little bit description about that why we use asbestos or why we are not using asbestos as filtration medium. Suitable filters will prevent the passage of microorganisms, but the filtration must be followed by an aseptic transfer. If we filtered by the sterilization or for the sterilization purposes, filtration is done, and after that particular operation we should follow the aseptic techniques while transferring of the solution to the final container, which are then immediately sealed with great care to exclude any recontamination. Aseptic process, aseptic condition should be carried out after the filtration by the suitable filters that will filter, that will prevent any passage of microorganism, any contamination, and we should immediately transfer aseptically to the final container, and the final container should be immediately sealed with great cautions in order to avoid any recontamination in the product at the final stage of the filling and sealing. Usually membranes are not greater than 0.22 micron, that is the size of the 0.22 micron. Nominal pore size should be used. The effectiveness of the filtration method must be validated if larger pore sizes are employed. The fourth process that is termed as ionizing radiation for sterilization. Sterilization of certain active ingredients, that is active pharmaceutical ingredients or API, drug products, formulations and medical devices in the final container or package may be achieved by exposure to ionizing radiation in the form of gamma radiation, and gamma radiation is one of the form of the ionizing radiation, that is a pharmaceutical radioisotopic source, and the source is cobalt. Cobalt is one of the source of the gamma radiation, and cobalt 60 are electrons energized by suitable electron accelerator, and laws and regulation for protection against radiation must be respected. While performing the sterilization by radiation in the final container or package, and by exposing it to the ionizing radiation, for example the gamma radiation, the standard operating procedure or laws and regulation in order to protect the environment, the personnel working over there and that particular area, the regulation should be followed. Gamma radiation electron beams are used to effect ionization of the molecules in the microorganism, and by this way the mutations are thus found in the DNA, and these reactions alter replication, and this way the sterilization is done. The last one, that is the gas sterilization, that is the PEP method of sterilization, that is the gas sterilization. Before going to discuss this one, you should note that gamma radiation, mutation or destruction of DNA or proteins, and must occur by the radiation, ionizing radiation as well. And the last one, that is gas sterilization, the active agent or active pharmaceutical, the active agent of gas sterilization process can be ethylene oxide or any other highly volatile substances, and ethylene oxide is one of the gases, source of gases that is used, and you can see not only the ethylene oxide, ozone and chlorate, formaldehyde, and certain other gases, agents. These are used for sterilization purposes, which is termed as gas sterilization. The highly flammable and potentially explosive nature of such agents is one of the disadvantages unless they are mixed with, in order to avoid this problem of the potentially explosiveness nature and highly flammable nature, which is the disadvantage of the gas sterilization, and in order to avoid these disadvantages, we should overcome these highlighted red disadvantages, and then we will use this process of gas sterilization. If we not overcome the highly flammability and potentially explosiveness nature of the gases, we cannot use, because it is dangerous, and by overcoming these advantages, how we will overcome? We will mix with suitable inert gases to reduce their highly toxicity, highly toxic properties, and the possibility of toxic residues that remaining in treated materials, and their highly flammability and explosive nature will be also minimized by mixing it with the suitable inert gases. The whole process is difficult to control and should only be considered if no other sterilization processes can be used. Is the final choice, because controlling these disadvantages and their toxic nature, highly toxic properties, and their residues that remaining in the treated material, which are treated by the gas, and that's why using the gas sterilization, they sterilize the residue, may be part of the formulation or part of the material which we have treated by a gas, and by this way we sterilize it. And if any other method of sterilization can be performed for the material, then we will not focus on this one, and we will prefer the other method, because controlling this process is very much difficult. It must only be carried out under the supervision of highly skilled staff in order to get the optimized sterilization and minimize the chances of errors, minimize the errors. And these are the different methods that I have told you about the sterilization and the different methods of sterilization. There are certain points which is considered as a principle that involving the evaluation of sterilization method, that how we will evaluate sterilization method, and what will be a principle that will involve in that evaluation of sterilization method. We must consider some of the points, including to build sterility into the product. It is one of the basic principles for evaluating that we should build sterility inside the product and perform a maximum level of probability, and we should establish specification and performance characteristics. What are the specification and what are the performance criteria and salient features we must consider for evaluation of sterilization processes to provide greatest assurance of support of the result, that we are sure that the results are, we are confident that the results are supported by using the assurance level, that is quality assurance level of this process of sterilization. In short, we say QAL, quality assurance level. Specific methodology, process and equipment, and methodology should be followed. It is a standard operating procedure. The processing and equipment used for that particular purpose should be specifically used. Final product testing using validated analytical method after the sterilization of the product. A suitable validated, that is validated as a functional, the efficient method should be used for testing the final product which we have processed for sterilization. And if the method is not validated, the testing method, then it is not confident, or we are really not confident for that one. That's why the final product testing should be done using the validated analytical method. And finally, the verification, calibration and maintenance of equipment used in that particular process. I told you about the calibration, that what is the calibration and what is the purpose of calibration, and how we will verify the calibration using suitable calibration methods we should follow. The verification and calibration, and if need any maintenance and equipment, we should get through the maintenance as well. References: Lyckman. Here the Lyckman as pharmaceutical dosage form, parenteral medication, 2017, and Gupta, role of environmental monitoring and microbiological testing during manufacture of sterile drugs and biologics. It is the American Pharmaceutical Review, 46 to 45, and these are the pages consulted. Research paper, that is a review paper, and you can see you can consult this one as. Let's overview the today topic. That was we have studied in the today topic, but a little bit about the review of today topic on the sterilization. It is mandatory to tell you about certain terminologies that is used in the sterilization. First of all, I will focus before the review on that particular terminologies that you have studied in the previous semester in the microbiology or any other courses related to the sterilization. Note these terminologies: disinfection, the agent that causes A disinfectant is a chemical or physical agent that is applied to inanimate object to kill microbes. The non-living objects or materials to kill the microbes. Typically, an antiseptic is a chemical agent that is applied to living tissues to kill microbes. And note that all disinfectants are antiseptics, because an antiseptic additionally must not be so harsh that it damages living tissue. That all the disinfectants are antiseptic. It is not mandatory for the disinfectants. Should be that not all disinfectants are antiseptic. Additional requirements antiseptic and disinfectant. What is antiseptic and what is disinfectant? Disinfection means reducing the number of microorganisms in a sample, and disinfection is not responsible for sterilization, not capability of sterilization. And by sterilization, as I told you, it is complete killing or removing all form of microorganism. And after that, I told you about the method of sterilization according to USP, the different method, as well as I told you that the three methods of sterilization which are used for parental products, including steam sterilization, dry heat sterilization, and sterilization performed by filtration method, except from the gas and ionizing radiation, which are widely used for the devices and surgical material. And if there is any other choice of the sterilization method, it will not prefer the gas sterilization and ionizing radiation. And after that, I told you about the steam sterilization we have discussed in detail. As an example, and the temperature, time, and pressure has to be adjusted, and this method is used whenever possible for the aqueous preparation for surgical lesion and medical devices as well. We have discussed in detail under dry heat sterilization and what are the different materials, example of the different materials like glass pairs, powders, oils, and some of the oil-based injections which are processed by this method. And we have also learned about the temperature and manual sterilization time and the conditions. These are the conditions for dry heat sterilization in the table. If we increase the temperature, then what will be the effect on the fine, as well as a filtration method. What is the role of filtration method, and why we prefer, and what are the different selection criteria of filters, suitable filters used, and ionizing radiation, for example the cobalt 60, there is a suitable radioactive isotopes, or gamma radiation, forming gamma radiation, and sources cobalt 60, and special precautions of protection related laws and regulation for the protection of the radiation exposed to the environment, to the personal. That should be of prime importance. And there is the mechanism by which affect the microorganism, and gas sterilization, and the major disadvantages, and how we will remove this problem, these related problems. We will mix it with the gases, with the suitable inert gases, and by using suitable inert gases, the toxicity, the toxic nature, and the possibility of the toxic residues that remaining in the treated material by the gas sterilization. And finally, we have focused on the evaluation of sterilization method, that what are the principles involved, and the evaluation of sterilization processes. The 7 points, one by one, we have discussed in detail. And finally, the references. Thank you all for your attention. Inshallah, we will discuss this topic in the online Google Meet session, as well as I have uploaded for you people, and the other format as well, that is handout and detailed PowerPoints. Thank you all, and we will discuss inshallah in the online Google Meet session on a prescribed time.